Now, on the previous test, you had to find the domain and range of a graph. What graph did you have to find the domain and range of? A circle. And so remember, when we talked about domain, the domain is the set of all x coordinates. Okay? And the range, that was domain, and the range is the set of all y coordinates on this graph. And so when we found the domain and range on the graph of a circle, to find the domain, we went from left to right along the x-axis. And so we discussed the fact that to find out the x-coordinates that these points take on, that's on the graph, you kind of look at where the most left-hand point on the graph. So that's here, right here. And then the most right-hand point of the graph is here. And so when you look at this, you have to determine what those x-coordinates were. So let's say this x-coordinate right here is 6, and this x-coordinate, let's say, is 10. What would have been the domain? It will be the interval from what? Bracket 6 to bracket 10, okay? So that's how you did the domain and range on the first test. The range is a set of what? Y coordinates. So that's where we went from bottom up. And remember, when writing an interval, you always go from smallest to largest. So that's why for the domain, I went from left to right. And for range, I go from bottom up. But when I go from bottom up, this is the first point I get to. That's the lowest point of the graph. So what you got to do is find out what that y coordinate is. So let's say this y coordinate is 4. And over here, the highest point of the graph is here. We got to find out where that y coordinate is. Let's say the y coordinate is 12. What would have been the range? The range would have been bracket 4 to what? 12. And brackets because all those points were on the graph. All those points were on the graph. Okay. Now, reviewing the idea of the circle, finding the domain and range, let's look at the first graph that's on that handout. So it should look like this. And you want to find the domain and range of the following functions. Now, these are all functions. Now, was this a function?
Yes.
No, it fails the vertical line test. It's a circle. That was not a function. Okay? But the ones we're about to look at are functions. All right, now, just be aware that if you don't see any arrow, just make sure you understand that there is an arrow there. So just put an arrow here. Put an arrow. All right, let's talk about domain and range. The range is easier to look at in this case. So let's look at the range first. Remember, the range, you go from where? Bottom up along the y-axis. So watch what I'm doing. And I'm going along the y-axis. And tell me when to stop. And I want you to tell me when to stop when the ruler touches the graph. Stop. Okay? So you got to tell me where that y value is. So that y value is -1. Tell me, I'm keep on going, so that's my lowest y value, right? So I'm going to keep on going and tell me when to stop. It never stops because the arrows implies it keeps on going, right? So that's to what idea? Infinity. Okay, very good. So now the range, I'm going to ask you this, is this point on the graph? Yes, so you can use a bracket. Bracket, -1 all the way to what? Infinity. And remember, infinity and negative infinity, you always use parentheses. So that's your range. All right, so that's where we're at. So the range here was easier to deal with. Now let's look at the domain. All right, domain, you go from along the x-axis. I'm going to go from left to right. Now you see this arrow. This arrow implies it keeps on going, right? Okay, so you got to visualize what I'm about to tell you. So this means, I'm going to kind of put this all the way to the bottom here. This means this, correct? Keeps on going. So is there, when I go from left to right, is there a point on the graph where I get the smallest x value? No, because this arrow keeps on going. So basically, if you look at this x-axis, I'm going all the way at the end to what idea? Negative infinity. So I'm going from negative infinity all the way to what? Does it ever stop? Does it ever stop? No, because this arrow implies it keeps on going, right? So at some point, when x is 1 billion, when x is 1 billion, am I going to get a point on the graph? Yes. Am I going to get a point on the graph if x is 1 billion? Yes. If x is 200 billion, am I going to get a point on the graph? Yes. So what's the domain? Negative infinity to infinity. And remember, with infinity, negative infinity, you always use parentheses. So you got to look at those arrows. If there's arrows involved, you got to look at them. Let's get number 2. And you need to compare number 1 with number 2. There are no arrows there, so it's understood to be arrows, though, just like that. The range is easier to deal with in this case. So let's look at the range first. When finding the range, you go from bottom up. Notice the arrows here are pointing where? Down. So I'm going to ask you, when we did number 1, I started touching the graph when y was what? -1. Here, where do I start touching the graph? Negative infinity, because this arrow keeps on going down. There is no smallest y value because of those arrows. But tell me where to stop.
2.
At 2. So there is a largest y value, right? Right here. That's my largest y value. So my range is going to be from negative infinity to what? 2 with a bracket. Compare those two. Make sure you understand the difference between those two. In the first one, the arrows are pointing up. In this one, the arrows are pointing down. Now, these are parabolas, so when we get into graphing these, you're going to be finding domain and range also with those. The domain is kind of like number 1. See how this arrow just keeps on going like this? So I'm going to ask you this. If x is, let's say, -1 billion, am I going to get a point on the graph? Yes. -500 billion. Yes. So in fact, the domain is going from where? Negative infinity to infinity. So any number for x is going to be on that graph. Any real number. That's not true for the y's. The largest y value I can get on this graph is what number? 2. So you can't say from negative infinity to infinity for range because you know the largest is 2. All right? Let's look at the next one. Parabola again. Is that the same one as the previous one? No. Okay, what's the range? Now actually, you can actually tell me the domain now. What's the domain? Negative infinity to infinity. What's the range? What's the smallest y value? 1 to what? Infinity. All right, so that's number 3. If you want to name it, number 3. Look at number 4, that line. You see you have arrow where the arrows are? No, that's the line this time. Is there a smallest y value? If I do the range, if I go from bottom up, is there a smallest y value? No, because that arrow keeps pushing this ruler down. So it's pushing it down all the way to what? Negative infinity. And then is there a largest y value? No, because this arrow keeps going up, right? So tell me what the range is. Negative infinity to infinity. Now let's do the domain. Domain, I go along the x-axis. Notice the arrows again. You see this arrow keeps pushing this ruler this way. Keeps pushing it. Towards what idea? Negative infinity. And when I go this way to the right, do I stop here? No, why not? Because that arrow keeps on going. So that means this line keeps on going like this, all the way to what? Infinity. Now remember, you're going along the x-axis. Some students get confused. You see how this arrow is going down? So they think negative infinity. That's not what's happening. You got to go along the x-axis. So along the x-axis, you're going from negative to what? Positive. Along the y-axis, you're going from negative to what? Positive. All right? So don't get confused. Don't think that since this arrow is going up, you're going to say a positive infinity to negative infinity. That's not how you read it. You read along the x-axis going from left to right. So this idea is pointing towards what idea here? Negative infinity. So I'm going from negative infinity all the way to what? Positive infinity. All right, so the domain and range are the same here in terms of intervals. All right, number 5. Okay, these are arrows right here. Number 5. Let's talk about the range. You see this arrow keeps going down like this? And this arrow keeps going up like this? So tell me something about the range. What do you think the range is? Negative infinity to infinity. All right, now think about what our discussion a while ago. You have the arrow pointing down like this and the arrow pointing up like this. So what do you think the domain is? Negative infinity to infinity. Because when you go like this way, you might say, well, this is going straight up. No, it's not. It's actually doing this. But if I ask you, when x is 1 billion, am I going to get a point on the graph? Yes. So you can say negative infinity to what? Infinity. All right, let's look at the next one. Domain and range. All right, so over here, let's do the range first. Let's do the range first. I'll go from along the y-axis from bottom up. Where do I start touching the graph when y is what? Negative 1. Where do I end up stop touching the graph? At positive 1. So negative 1 to 1 is my range. From negative 1 to what? Positive 1. Those are all the y values that's on the graph. There are no other y values on the graph. For example, on the graph, am I ever going to get a y value of 3? No, because y is 3 here. There's no graph when y is 3. It just goes from negative 1 to 1. Now, look at the domain. What do you think the domain is, guys? Because the arrows, right? See, this arrow is pointing towards this way. So from negative infinity to what? I never stop because of the arrow. It keeps on going. So negative infinity to infinity. All right. So that was number 6. Go to number 7. Number 7. Those are arrows. All right. Tell me something about the range. The range first. So the range, I go from bottom up. See this arrow that's pointing down? It keeps pushing the ruler down, right? So that's pushing it towards what concept? Negative infinity. So I'm going up now. Negative infinity to 3. That's where it stops. Don't forget, though, infinity, negative infinity, you always use parentheses. Now tell me something about the domain. Yeah, so I'm going from, go along the x-axis. So that, see how this arrow is pointing down like this? So always ask yourself, is negative 1 billion going to be on the graph? If I extend this, is negative 1 billion going to be on the graph? Yes. When x is negative 1 billion, I'm going to get a y value. And then the same thing for If you keep on going to the left, negative 500 billion, there's going to be a point on the graph. So I'm going from negative infinity all the way to positive infinity because the arrow keeps on going this way. All right. Now, 8. Are there any arrows in 8? No. Those are endpoints. See the closed dots? Those are endpoints. So let's talk about the domain first. Domain. So when I go along the x-axis, I start when x is what? Negative 1. So bracket negative 1, comma, and I end when x is what? 5. With bracket. So that's my domain. Negative 1 to 5. Use a rule if you got to. Use something like that to help you. The range, when I go along the y-axis, I start touching the graph when y is what? 1. And I end when y is what? 7. So that's your range. So make sure you understand what domain and range tells you. In terms of these points that's on the graph, the y values that's on the graph are always going to be between what two numbers? The y values on the graph are always going to be between what two numbers? 1 and 7. No other number. So 1.2 is going to be on the graph, 1.28 is on the graph, and so on. Am I going to get a y value of 8 ever on this graph? No, because 8's here. There's no point of the graph where y is 8. Same thing for domain. Am I ever going to get an x value of 7? Here's where x is 7. Am I going to get a x value of 7? No. The graph, there's no graph when x is 7. Number 9. What is the difference between number 9 and all the others that you've seen? The open circle, very good. Open circle means it's not part of the graph. It's not a solution. Remember when you see a graph, all those points are solutions? Remember when we talked about the circle? And we said that all those points on the circle are solutions? There are points on the circle? So I'm going to ask you this. Is this point right here part of the circle? I'm sorry, part of this segment? No, because it's open. Is this point part of the segment?
Yes.
Yes. All right. Now listen carefully how you're going to write your interval with this. When we did the others, for example, the domain and range here, we use brackets, right? Why did I use a bracket at negative 1 right here?
Because it was included.
Because that was a closed circle. It was included. If it's an open circle, it is not included. In that case, you have to use what? Parentheses. You got to remember that. Open parentheses, closed bracket. Kind of like the inequalities, right? Remember when you first started talking about inequalities, we talked about whether to use a open circle, closed circle versus parentheses brackets? It's that same idea. So let's talk about the range first. I'll go from bottom up. Now remember, if there's no tick marks, if there's no numbers there, assume that each tick mark represents one unit. So this is 1, this is 1, this is 2, this is 2, and so on, okay? So the range, when I start from bottom up, I start touching the graph when I'm here, right? That's at what y value? 1. But I can't use it, so I've got to put what with it? Parentheses. Parentheses 1, comma, all the way to, what's that? 3, 4, 5, 6, 7? With a what, though? Bracket. Very good. Notice the difference. So there's no, if it's an open circle, you can use parentheses. If it's a closed circle, you use brackets. Now the domain. Where do I start touching the graph along the x-axis? Parentheses or brackets? Very good. All the way to what x value? That's a 4. All right. With a bracket. All right. So that's number 9. Let's look at number 10. Let's talk about range first. All right, so when I go from bottom up, what's the smallest y value I see? Bracket or parentheses? Bracket. All the way to 0. All right, now, this one's a little bit tricky. It's a little bit tricky. Notice that when y is 0, how many points do I kind of see on that graph? 2. There's an open circle and there's a what? Closed one. So it is possible for, or in this case, there is a point on the graph when y is what? 0. So I have to use a bracket because of this right here. That is closed and this is what? Open, so you're still going to use closed. Okay, I'm going to ask you this. If I had extended this and this was an open circle here, then your endpoint would have been what? Parentheses. Okay? All right, so be a little bit careful when it kind of looks like this. It is tricky. Most cases, the ones that you can see are going to be straightforward, but this one's a little bit trickier in that sense. So this is open, this is closed, but since it is possible, remember when we talked about what this means, I'm going to ask you, is there a place on the graph when y is 0? You're going to say yes or no. Yes. Is it this one or is it this one? It's that one right here. That's where y is 0. Okay? That's how you got to look at it. There is a place on the graph when y is 0. It is here. Not here, because that's what? Open. But since there is a place where it is 0, I got to put a bracket. Now let's talk about the domain. Domain is going to be a little bit easier for you. That one's a little bit straightforward. Tell me where I start with a what? Parentheses. Tell me where I end with a what? Bracket. That one was more straightforward. Okay. Number 11. Let's talk about the range first. When I look at the range, where do I start? Is that closed or open? Closed. So that's going to be bracket. And this arrow keeps on going, right? So all the way to what? Infinity. Domain. Go along the x-axis. Nose the ruler. When do I start touching the graph? When x is what? 0. Good. Bracket all the way to what? Infinity. All right? Okay. Now,